Today we will be covering two sections, section 11.4 and 11.5. 11.4 focuses on quadrilaterals and 11.5 focuses on polygons. So these all wrap together into one of our geometric topics. A quadrilateral is a simple closed figure with four sides and four angles. Sides must be straight lines, so they cannot have any curves, and the angles are on the inside. Simple means that the figures cannot overlap themselves. So if we look at the first example of not a quadrilateral, we have 1, 2, 3, 4 sides, but the two sides in the middle overlap. Therefore, it is not a simple figure. All of these figures on the board are closed, meaning there's no gaps within their sides or within their pieces. The second non-quadrilateral on the board is not a quadrilateral because of this curve. We are not allowed to have curves in our quadrilateral. And the last one has 5 sides. The four on the left are quadrilaterals, all have 4 sides and 4 angles. The other important piece of information you are going to want to know about a quadrilateral is the angles add up to 360 degrees. So just like our triangles add up to 180, quadrilaterals add up to 360 degrees. Part of your homework tonight is going to be classifying quadrilaterals. You can classify quadrilaterals based on their sides and on their angles. This chart can be found on page 613 in your book. So if you want to copy down the chart or just refer back to page 613 in your book. We have our quadrilaterals up at the top. That is all 4-sided and 4-angled figures. Breaking off of that, one of our subcategories is trapezoids. That means that there are quadrilaterals with exactly one set of parallel sides. Notice this is on the top and bottom of this figure. Trapezoids can also look like this. Again, the top and bottom sides are parallel. The next large category is the parallelogram. That is a quadrilateral that has opposite sides are parallel and congruent. So notice the sides on the top and the bottom, they have these 2 arrows acknowledging that they are parallel and the 2 dash marks acknowledging that they're congruent. On the left and the right, same thing. 1 arrow to indicate parallel and 1 dash mark to indicate that they are congruent. Within the parallelogram category, we have a few additional breakdowns. The rectangle falls under the parallelogram, so we have parallel sides, and we have the congruent sides, so it fits the parallelogram description, and it also has 4 right angles, so its 4 angles are congruent. The rhombus, again, fits under parallelogram. We have 2 sets of parallel sides. The additional qualification for the rhombus is that the 4 sides are congruent. So all 4 sides on a rhombus are congruent. The square brings it all together. We have 2 sets of parallel sides. It has all 4 sides congruent and all 4 angles congruent. So we bring all of the other parallelogram classifications in for the square. When you are labeling a quadrilateral, you want to be as specific as possible. So if you have a square, you would label it a square, not a parallelogram. Your homework tonight will give you different pictures to look at and to classify. So if we are looking at the one on the left, first thing you should always check is for the parallel sides. This one has a parallel side on the left and the right, but not on the top and the bottom. If you extended those two sides, they are getting closer and will eventually touch. With one set of parallel sides, this is a trapezoid. If we move to the figure on the right, if we extend the sides, again, we would see that the first set, the left and the right, will eventually run into each other. Same thing occurs if we extend the top and the bottom side. Eventually, they would continue and run into each other. So we would simply label this a quadrilateral because it does not fall into a more specific category. So part of your homework is simply going to be classifying the quadrilaterals. The other is going to be using the idea that a quadrilateral adds up to 360 degrees. So they're going to give you angle measurements on a quadrilateral, and they ask you to find the value of x. So we know that all the sides have to add up to 360 degrees. And we recognize that this corner right here means the angle is 90 degrees. So I can take my four angles, 90 degrees plus 75 plus 7, x plus 7 plus x, and that has to add up to 360 degrees. Once we have our measurements, we want to simplify our equation. So we have 2x, and then we need to add up the values of our other angles. So we have 2x plus 172 is equal to 360. Our next step for solving, we subtract 172 from 360, and we get 188. Last step to find x is dividing by 2, and we add up to 94. Last step to answering these questions is going back up to the top and saying that our angles are 94 degrees for x, and when we have x plus 7, we get 101 degrees. So for section 11.4, your homework will be classifying the quadrilaterals and finding missing angle measurements. When we move into 11.5, we are now looking at polygons. So this is looking at all geometric figures that are simple, closed, and have 3 or more sides. The sides can only intersect at the end point. That is the simple part. So there is no overlapping of the sides. And the closed means that there are no gaps within the figure. Simple also means that there is no curves within the sides. A regular polygon, which is what we are going to be looking at today, has all of its sides and all of its angles congruent. So backing up to the quadrilaterals that we just talked about, the square is the regular quadrilateral because it has all 4 angles congruent and all 4 sides congruent. So the square is the regular version of a quadrilateral. The first part of your homework for polygons is going to be identifying whether it is a polygon and explaining why. So if we're looking at example A, we have all of the sides are straight lines. It is a closed figure, and there are no overlap between the sides. So we would say, yes, it is a polygon because it is simple and closed. B is not a polygon because it is curved. We have a curved side, meaning it is not a polygon. Part C, again, straight sides, no overlap and no gaps. So it is yes, because it is simple and closed. Same thing occurs with D. Yes, because it is simple and closed. And part E is no, again because we have a curved side. To give you an example that is not closed, it could be a figure that looks something like this, and we would say no because it is an open shape. The sides do not come together to meet. Just like we can classify quadrilaterals, we can also classify polygons. So we've looked at a couple of these already. Back in section 2, we were talking about triangles. Those have 3 sides. Earlier in this lesson, we talked about quadrilaterals. Those have 4 sides. Pentagons are the next type, and those each have 5 sides. Hexagons have 6. Heptagons have 7 sides. Octagons have 8. Nonagons have 9 sides each, and decagons have 10. The last one that we have beyond 10 that has a specific name is called a dodecagon that has 12 sides. Other than that, if we have 11 or anything other than 12, anything greater than 12, we simply label it as an n-gon. So for example, if your polygon had 14 sides, it would be labeled as a 14-gon. The gon part is standing for the polygon. The number is telling you the number of sides. So, classifying polygons for your homework, looking at the first one, we cannot even classify it because of its curved side. So we would simply label it not a polygon. If we come to the one in the middle, we have a simple closed figure, no overlaps and no gaps. So then we count the sides. 1, 2, 3, 4, 5, 6. 6 sides, giving us a hexagon. And again with the last one, simple and closed, no gaps, no overlap, counting 1, 2, 3, 4, 5, 6, 7, giving us a heptagon. So even though these figures do not look like your typical hexagon and heptagon, you still count the sides and label based on the number of sides. Just like we looked at the angles of a quadrilateral, we are also going to look at the angles of a polygon, specifically the interior angles, which are the angles on the inside of the polygon. So we're looking at the angles on the inside. The interior angles of any polygon can be found by the formula 180 and then in parentheses n minus 2. N stands for the number of sides of the polygon. So we take the number of sides, subtract 2, and we can multiply by 180 to figure out the sum of the angles of our polygon. So if we have, for example, a dodecagon, meaning that we have 12 sides, using the formula, we would take 180 times 12 minus 2. 12 minus 2 gives us 10. 180 times 10 gives us 1,800 degrees on the inside of a dodecagon. If we have a 16gon, we would take 180 times 16 minus 2. 16 minus 2 gives us 14. And 14 times 180 is 2,520 degrees. So we are able to use this formula to figure out the total number of degrees inside a polygon. If it asks you for the specific angle measurement of a regular polygon, the formula changes slightly. So we're looking for the interior angle, the measure of each interior angle. You still find the total number of degrees. That's the top part of the formula. But then you divide by n, which is the number of sides, which is also the number of angles. So for example, in a quadrilateral, we have 180 times 4 minus 2 divided by 4. Meaning I have 180 times 2 divided by the 4 angles. 360 degrees divided by 4 angles means the angle of a regular quadrilateral has to be 90 degrees. We know that a square, each angle is 90 degrees. That is why this formula works. So if I have a pentagon has 5 sides. So we take our formula, 180 times 5 minus 2 divided by 5. 180 times 3 dividing by 5 gives us 540 degrees, split up into 5 angles. So each angle inside a pentagon is 108 degrees. For the hexagon, we know that we have 6 sides, which means we have 6 angles. So 180 times 6 minus 2 divided by 6, giving us 180 times 4 divided by our 6 angles, means we are taking 720 degrees, splitting it into 6 angles, giving us each angle measuring 120 degrees. When you are done with your notes, bring them up to the desk so that I can give you your homework assignment.